us start with this last chapter, analysis of plane frame structures by flexibility method. This flexibility method is called as force method as well as compatibility method also it is called. So this flexibility method already I told the force displacement relationship. The force displacement relationship can be expressed as in matrix form. Of course, it is expressed as D is equal to F into P. So, where this F is called is flexibility matrix. This is called flexibility matrix. And this is displacement vector. Displacement vector. And of course, this is force vector. In this flexibility coefficient, that is any element Fij in this flexibility matrix is defined as the force developed, not force, displacement. The displacement developed on account of unit force. That is, displacement developed at I coordinate due to on account of unit force at j coordinate. This particular definition Fij holds good, and using this definition you have to evaluate this flexibility coefficient similar to stiffness coefficient, wherein along each coordinate you are applying unit displacement and you are evaluating the force. Here it is exactly the corollary. You have to apply unit force at any coordinate and evaluate the displacement. So first you have to develop the flexibility matrix, and after determining the degree of static indeterminacy, and then you have to make the structure determinate. Then after making it determinate, some inconsistency in deformation will occur at some points, because during the exercise of making the structure determinate, you will remove some forces. Since you are removing some forces, actually at that particular point, restraint will be lost and there will be displacement bound to occur at those points, and that displacement you have to evaluate. Then using this relationship, you can determine that unknown redundant force. So let us first give the steps to be followed in the analysis of structures. Steps to be followed. The first step is find degree of static indeterminacy. Degree of static indeterminacy. This already you know how to determine the degree of static indeterminacy. In the case of beams which are axially rigid, that total static indeterminacy is 2m plus or minus 2j. If it is plane frame, rigid plane frame, it is 3m plus or minus 3j. Minus some external imposed condition like internal hinge and all those things. After finding this degree of indeterminacy and identify them with coordinates, and identify them with suitable coordinates. So the coordinates means already I have told, it indicates the positive direction of that indeterminacy, whatever we have. Identify them with suitable indeterminacy. That means you have to make the structure determinate by removing that. So find the static indeterminacy, and second, make structure determinate, make structure determinate by introducing releases in the form of force at suitable points, then evaluate the displacements along these releases due to given loads. Then third, find flexibility matrix. Find flexibility matrix F. Then after finding this, use force displacement relation to evaluate redundants. And redundants are nothing but these released forces. Redundants are released forces. That's all. The main steps are four. Then once you have determined those redundant forces, you can find out the other forces by ordinary equations of equilibrium, and you can plot the bending moment diagram. So main steps we are following in the flexibility method are only these four. Here main exercise is this flexibility matrix development as well as this evaluation of displacements. In other words, it is basically an exercise of evaluating the displacements on account of some loadings, so that you know already. They are all mainly with respect to determinate structures, because we are making the structure determinate. The moment it is determinate, you have to evaluate those displacements. It is just nothing but the exercise of evaluating the displacement. You can remember some for standard cases, the displacement, then you can work any problem with ease. There is no problem with us. Now straight away we'll start working problem on beams. How to solve these beam problems, that is statically